In the Horn of Africa, climate variability has caused devastation from floods, droughts, and disease outbreaks. But what is climate variability?
The Earth's climate is a dynamical system that naturally varies on seasonal, decadal, centennial, and longer timescales. Each up and down fluctuation can lead to conditions which are warmer or colder, wetter or drier, more stormy or less stormy. The effects of climate variability ripple throughout the environment and society, indeed touching nearly all aspects of our civilization, whether you're in New York City, the European forests, the Sahel, or the Kenyan plains.
How does climate variability affect the Horn of Africa?
In the tropics, you have variations from year to year that can be quite severe, very big variations in the amount of rainfall that you get. And we understand on a very basic level why this is true, that if you're in a place where the rain comes when this band of raininess called the Intertropical Convergence Zone comes over you, okay, it rains when that comes over you, and it doesn't rain very much when that doesn't come over you. And if something gets changed in the climate system so that that does not come over you, then it doesn't rain.
First one. Climate variability in the Horn of Africa is related mostly to ENSO variability.
ENSO, or El Niño Southern Oscillation, is a quasi-periodic climate pattern that occurs across the tropical Pacific every 3 to 7 years. There are two varying phases of ENSO, El Niño and La Niña. El Niño refers to the warm phase of the cycle, in which the easterly surface winds, commonly known as trade winds, are relaxed, resulting in above-average sea surface temperatures in the central and eastern Pacific. La Niña is the cold phase of the ENSO cycle. Under La Niña, the trade winds are strengthened, resulting in colder than average sea surface temperature in the eastern and central Pacific. ENSO is related to the Indian Ocean sea surface temperatures, which in turn affect precipitation in the Horn of Africa. Changes in temperature, precipitation, and humidity, often related to ENSO, are associated with upsurges of waterborne diseases such as cholera and vector-borne pathogens such as malaria. Climate variability can be forecasted, and the potential exists to predict the likelihood of outbreaks of infectious diseases. Climate forecasting can provide the basis for a proactive approach to the spread of human diseases, mitigating or preventing outbreaks before they occur.
Coming from the malaria control program, the information on climate is very vital for the control of epidemics in the highlands of Kenya. We've been having very serious epidemics, and we all know that it's related to climate. And so, if we are able to get information on the climate and be able to predict an epidemic, then we are likely to actually avert that epidemic and be prepared for response.
How can we monitor climate variability?
For the season, where the central part of the Greater Horn is affected by rain by ENSO, for that season, October through December, we not only have somewhat of a good relationship between ENSO and the rainfall there, but we also have good prediction of what ENSO is going to be at that time. So that is our main point of leverage in helping the Red Cross. Because when there's more rain than normal, there's often a tendency for more malaria than normal.
The International Research Institute for Climate and Society at Columbia University has created tools that allow users to see when and for how long the combination of climatic conditions may be suitable for malaria transmission. The graph in the center shows when precipitation, temperature, and humidity are favorable for malaria transmission for a given location. This data is averaged across a 50-year historical record. The graphs on the right show the percent occurrence of rainfall, temperature, and relative humidity for each month. In this case, we see that precipitation is the limiting factor for transmission in this area, so unseasonable increase in rainfall could create new windows of transmission. The climate system is chaotic in nature, therefore we can't predict the exact amount of rainfall we will have for a given season. Because of this, the ENSO-based forecasts divide the outcomes into three possible scenarios: unusually wet, unusually dry, or normal. In this map, we can see that we have a 55% chance of having an unusually wet season, 15% chance of it being unusually dry, and 30% chance of it being close to normal. Current ENSO forecast capabilities, combined with the understanding of the links between climate and health, can be used in assessing the vulnerability of populations to outbreaks of infectious diseases and in determining the likelihood of risks or epidemics.
Malaria is preventable and curable. Why are we as Kenyans allowing such a disease to kill our people? We should actually use all efforts available to prevent this disease, and if we can actually predict such epidemics, we should be in a position to actually stop and avert this catastrophe.